Welcome back to the Dynamic Programming Series Part 1. Today we understand how recursion works. So without any further introduction, let's dive into this question. Lead code 494 target sum. Here we were given an integer array numbers and an integer value target. We need to build an expression using symbols plus and minus, and after concatenating, if we are able to evaluate that expression that leads to a target value, that will be our one choice. For example, consider an example 2, 1. You can add a plus and minus before this expressions. You may do any magics. So if we end up doing this plus 2 and minus 1 expression, you may end up with a value 1, right? That leads to a target value. If we for assumption, if our target value is 1, this is one way that leads to a target 1, plus 2 and minus 1. One way of creating an expression out of these two numbers. So we need to return the different expressions that we can build which evaluates to the target. So consider this example which has a target 3. So these are the possible ways of constructing the numbers. These are the possible ways of building an expression out of those numbers which leads to a target value 3. There are 5 ways. So initially we were with index 0 and with 0 at 0 total of 0 at this index. So at each value we add only two choices, either we add that value or subtract that value. So if we add that value from the 0th index, we may end up with, at index 1 we may have with index 1, total 1. And also we had the other choice of subtracting that number. So if we subtract that number, we have 1, and at index 1 we are left with minus 1 total, and so on and so forth. This is the best way of visualizing our recursion using a decision tree. And also have used this data structure which holds the index comma total value. So this was used to cache the memory. So if the value here, we can see that 2, 0 is repeated, right? So if the value exists in our memory, so we don't need to compute it again. We can fetch that value from the cache value. So without any further, let's code it up. We define a data structure that holds index comma total, as we seen in the drawing, that holds an index of type integer, and total is also type integer, value is also type of integer. We were holding the index comma total. So at 0th index we were left with 0 at 0 and total of 0, right? And also we are also need to get to the target value, right? So this is the one way that leads to a target value 3. I had drawn only 1. If we are out of bounds and our value is 3, we need to cache this whole expression. So let's create an array and let's create our recursion function, and let's call that as backtrack, and that takes two numbers. One is the index, I name it as I, and the other one is the total. For every recursion we need to have two conditions. One is the base case and other one is the recursive call. Here the base case is when we are out of bounds and our value is 3. See here the length of the array is 5. We can iterate only up to 4, right? If we are out of bounds and it leads to 5, and if we are also calculating the total, right, on the right hand side, here the total 3 is equal to our given target. So we found one possible of way, right? So that's our base case. we are calculating if our total is our target, we found one way, or else we don't consider it. And also, as I said before, we are catching our memory, right? So if it exists in our memory, we return that. Sorry, I missed something. Here I is our base case, right? So when we out of bounds, here I equal to 5, right? We are out of bounds, and our target value is 3, and our total value is also 3. So this is our base case. We need to terminate it then. So that base case is this if condition, and this if condition is for catching. If that value exists in our memory, we return that memory. Sorry, we return that value. And time to call our recursive function. Let me copy this. As I said before, we had only two choices. Either we add that value or subtract that value, right? Right. And we are returning that value. This backtrack of 0, is, as we were starting from the 0, 0, right? That's our base. That's our starting point at 0th index, and with a total of 0, we need to calculate how many possible ways, which leads to a target value 3 and out of bounds value and out of bounds. So if we run this, yes, okay, it was pretty good. If you do like my content, do like, share and subscribe.